I'm going to show you now how to solve problems involving compound interest. So let's say you have $1,000 and you're going to invest this $1,000 at, let's be optimistic here and say you're getting 6% per year, and that's compounded annually for 5 years. So what that means is wherever you're investing your money, they're paying you 6% of all the money you have invested with them every year, and that's going to happen for 5 years, and they're calculating the interest once a year. That's what this part here means, compounded annually. Because it's compounded, you don't only receive interest on the original amount you put in, but as the value you have grows, you receive more interest because they're holding more of your money. The formula for doing this is that the amount that you end up with is equal to the principal amount times 1 plus the amount of interest per compounding period to the exponent of the number of compounding periods. So P is the principal. That is how much you've invested at the start, which in this case is the $1,000 you put in. I is the interest per compounding period. So if this is calculated every year, if it's compounded annually, compounded every year, 6% per year, that interest is 6%. Now remember, 6% is 0.06. And if you're not 100% sure on that, just take 6 and divide by 1,000 and you'll get 0.06. N is the number of compounding periods. So in this case, it's compounded once a year for 5 years, so you have 5 compounding periods. So I'm going to put all of this into my formula. The amount I end up with is the principal amount multiplied by 1 plus the amount of interest per compounding period. And the exponent is the number of compounding periods. So my amount is going to be 1,000 times 1.06 to the exponent 5. And that gives me 1338.23. I'm now going to change the question slightly. So we now have $1,000 and we're still receiving 6% per year. And we're still doing this for 5 years, but it's compounded monthly. For 5 years. So here's what this means. The interest is recalculated every month. So let's see how that affects things. So remember here in our original problem, we had $1,000 at 6% per year, compounded every year for 5 years. That means that every year you're receiving an additional 6% on top of what you already have. Whereas here, we're still receiving interest at a rate of 6% per year, but it's compounded monthly. So that means that we break that 6% per year into how many percent it would be every month, and we're recalculating this every month. So the principal amount is still 1,000. However, the interest and the number of compounding periods drastically change. The interest is how much of that 6% we have every month. So remember, 6% is 0.06. That's the amount of interest per year. But we're going to divide that by 12 because there are 12 months in a year. So I've got 0.06 divided by 12, which is 0.005. The number of compounding periods, we have 5 years, but we're going to multiply that by 12 months per year. So there are 60 compounding periods. As a general rule, you're going to see your interest go down and your number of compounding periods go up when it's compounded every month or perhaps 4 times a year. You'd call that quarterly, or twice a year. You'd call that semi-annually. So now the amount you end up with is your p-value, your principal, 1,000, times 1.005 to the exponent 60. So remember, in here, this is always 1 plus the amount of interest per compounding period. And the addition's real easy because there's a 0 there, so you just replace it with a 1 to add 1 to it. So the amount now is 1,000 times 1.005 to the 60. $1,348.85. So as you can see, if we have the same rate of interest, but it was compounded once a year, we end up with $1,338. And with that same rate of interest, but compounded every month, we end up with $1,348. So the more compounding periods you have, the faster this grows, because the more often the interest is recalculated. And remember, at each stage, you're getting interest on the interest. Let's solve one of these a little bit backwards. So let's say you want 10,000 in 5 years, okay? And you receive 8% per year, compounded monthly. How much must you invest today? So in 5 years, you want to be able to take $10,000 out to do something. If you invest, you're going to receive 8% per year, but it's compounded once a month. How much must you invest? So I'm telling you the amount you're ending up with now is 10,000. The interest is 8% per year, compounded monthly. So we're going to take 8% and divide it by 12. So that's 0.08 is 8% divided by 12. .0067. N is the number of compounding periods. In 5 years monthly, that's 60. And the principal amount, that's what we don't know. So I'm going to write down the equation. Remember, the amount is the principal amount times 1 plus the interest to the number of compounding periods. So the amount we want to end up with is 10,000. Principal is unknown. 1.0067, that's 1 plus I, where I is 0.0067. And then the exponent is 60. So if we rearrange that, to rearrange this, just watch. P is the principal, and it's being multiplied by this thing. The opposite of multiplying is dividing. So P is going to be equal to that amount divided by this to the exponent 60. So for P, I just need to take 10,000 and divide it by 1.0067 to the 60. And that gives me 6,698.78. So what that means is if you take $6,698.78 and invest it for 5 years while receiving 8% per year compounded monthly, you will end up with $10,000 in 5 years.